Welcome back. This is an Aleks homework video on predicting qualitatively how entropy changes with temperature and volume. Okay, so entropy. In an easy way that I can put this in my mind, it's randomness. So if I were to heat something up, say from a solid to a liquid, or a liquid to a gas, it's more random. So as temperature increases, entropy normally will increase. Okay. Now, it is also related to volume. So for instance, if I have a very small volume and it's very concentrated, and I put it into a bigger volume where there's more places for those molecules or ions or whatever to go, then it becomes more random. So the entropy would go up. So here's the rule of thumb. If you increase the volume and keep the temperature by itself, keep the temperature alone, and increase only the volume, you're going to have an increase in entropy. If you decrease the volume, you're going to have a decrease in entropy. That's if your temperature is by itself. So what you're going to see is that the entropy is proportional to an increase in temperature. So as T2 is higher, then it's going to be, you'll have a positive entropy. Also, the bigger the volume, you'll have a positive entropy. But you have to realize that's only if the other is held constant. So if you have an increase in temperature but volume is held constant, you can say it's going to be an increase in entropy. If you have a lowering temperature and the volume is constant, you'll have a lowering entropy. It works the same with volume. If you have an increased volume and the temperature stays, then it's an increased entropy. If you have a reduced volume, but the temperature stays, it'll be a reduced entropy. Okay. Now, if they ask you that both the volume and the temperature both go in the same direction, so both the volume go up and the temperature goes up, well, I'm still fine with saying that the entropy is going to go up. Since entropy is related to both of them, if they both go up, I can be sure that the entropy goes up. If they both go down, the entropy will go down. If you get the weird situation where they're asking you what the entropy change will be if one goes up, volume or temperature, and the other goes down, there's no way you can solve that problem, okay? Because you don't know what to attribute it to. You don't know whether it was the temperature that wins out over the volume or the volume that wins out of the temperature, so you have to say not enough information. So if you've got one and the other's held constant, fine. If it goes up, it's up. If it's down, it's down. That's no problem. If they both go in the same direction, if they both go up, then it's higher. If they both go down, it's lower. If you have one going up, volume or temperature, and the other coming down, you have to say not enough information. Okay, so I hope that gives you a little bit of a way to start thinking about this problem. So the first one that I see is that I've got nitrogen gas and then it expands. So the volume is getting bigger, but the temperature is held constant. All right? So if my volume is bigger and my temperature is constant, then entropy follows the increase in volume and it's going to be a positive entropy. Okay? The second one here, I've got some acetone, and the acetone condenses. All right, so the temperature is dropping, or you have a constant temperature, but it's getting smaller. It's getting into a smaller space. Okay, it's condensing. Same temperatures, so the volume would reduce, temperature stays the same, and in that case, since the volume is reducing and the temperature staying the same, your entropy goes down in this example, right? In the final example, I've got some helium gas, and the temperature is going up and the volume is going down. Do you see there's nothing I can do? I have no way of knowing what the answer is going to be with just this information. So I say not enough information. Okay? So you can't be totally terrified of this not enough information. You don't want to put it all the time because you're going to be wrong almost all the time. But in this case, there is not enough information, so you have to check that box. All right? So I hope you're doing well, and I hope this helps.